Okay, this time we're not going to be looking at sea ice climatologies like we did in the last exercise, but we are going to be looking at actual sea ice records. So this is going to be sea ice records from 1978 to present time, and this is going to be daily data. So every day we're going to have a measurement of sea ice in the Arctic and the Antarctic. So these are going to be much bigger data sets. And our data sources are going to be https://nsidc.org. That's the National Snow and Ice Data Center. And I've got that website up. Here it is. And just like before, we can navigate down here and go look for sea ice data. And our sea ice index, or our extent, is going to be our first record. And just like before, we're going to go to a download site, download via FTP. This is that optional user registration form. You're welcome to fill it out. We're going to bypass it. And then we're going to be looking for our data. So we're going to go to North, Daily Data, Data again, and here's the climatology file that we used in the last exercise. Here we're going to be using, here's the daily file. You notice it's much larger. It's 2.1 megabytes as opposed to 33.7 kilobytes. So let's go ahead and click on that. This is a comma separated value. This is a little hard to read because we have a very long last column, so it loops over onto the last line. But it looks like we have year, month, day, extent, whether or not it's missing, and source data. But we're going to go ahead and grab this. Say this is going to be our Arctic data. It's going to come from here. And our Antarctic data. Let's go back to the site. Let's go back, 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 back one more time. Click on South, daily data, data again, and here's the extent. Sea ice daily extent. We'll grab this FTP address and we'll put it in here for later. Okay, all right. So those are the two places we're gonna. R is gonna go onto the internet and get data for us. So let's go ahead and start. Let's call something arc. This is for our Arctic data. We're going to use the function read.csv again, which stands for reading comma separated values. And let's put our Arctic data set in here. Okay. And in this particular case, what we're going to do is not read in a header. So we're going to have header equals false. And that's because if we go back and we look at these data sets, you'll notice that there's two header lines here, which gets a little bit complicated. So we're just going to skip those first two lines, but we know what the different values are. We know it's year, month, day, extent, missing, and source data. So this is not going to be a problem for us. The header equals false, and we're going to skip the first two lines. Okay. Let's go ahead and run that. This may take a little while because it's a much bigger file. All right, there it is. ARC is 12,319 observations of 6 variables. So let's go ahead and take a look to see what that looks like. Head, ARC. Yeah, okay, so here's our first 5. There's our year, month, day, extent, whether or not it's missing. And then here's our source, and that's that larger line. That if you wanted to, you could go back and go to these original source files and check them out, but we're not going to do that. I can leave that for you for a later exercise. And then what we're going to do is really, since we're just going to be using the first 4 here, which is year, month, date, and sea ice extent, we're just going to overwrite ARC and just take the first 4 columns. So this is what we want, all rows in the first 4 columns of this thing, and we're just going to overwrite arc. So if we run this, now you'll see arc is just this many observations of 4 variables, and we look at the head of arc again, and you can see that's what it is, year, month, day, and extent. Okay, so in this case, we are going to have to mess around with our timestamps here because it's not just in one column. It's giving it to us in year, month, day, and there's lots of ways to do time. We saw last time it was day of year, but this is actually a date. So we need to deal with that. So we are going to paste the year, month, and day columns and turn them into a date that R can recognize. So we're going to use an interesting function here. Okay, so we're going to make an object called arc tm for arc time, and we're going to use the function paste. Alright, so what's paste going to do? Let's just do a help page on this. We are going to concatenate strings. So we're going to take different strings or different values and just paste them right together. So we're going to paste 1978 with 10 and 26 all together to make one date. And the way we're going to do that, we know the first column of arc is our year. So arc 1. And then we're going to paste next to that arc column 2, which is our day, which is our month. And arc 3 is our day, and we're going to separate these with a space. So that's what the separator is, character string to separate. So if we run this, you will see, let's take the look at the head of arc time. There it is. So there's our 1978, 10, 26, right? So that's all pasted together. So it's one string. That's what we have the quotes around it, one text string. We have to do one more step to let R know that this is a date. And so we're going to do arc tm one more time, and we're just going to overwrite this, but we're going to take this object that we had, and we're going to use a function called strp time. Now, there are many ways to handle time. I'm going to show you the easiest one to do it when you have a date string like this. But we're going to use strp time. This is a very powerful function. You can read through it on your own, but it's basically to convert between character representations of objects and classes of POSIX, which represent calendar dates and times. So we're converting a character string into an actual time that the computer recognizes. And there are so many ways to do this. You can deal with AM and PM and weeks and century and all those things. We're not going to be doing that to do this because there's lots of ways to measure time. We're doing it with year, month, and day. So we have to tell it that here's our text string, this arc time, this object that's holding our text streams, and we have to tell what format it is. Format is, and this is the kind of the funky part here, it goes like this: Y, capital Y for year, dash, %, lowercase for month, dash, lowercase d for day, and the time zone is going to be GMT. And so if you look down here, you'll see all the different demarc. Here's lowercase a for weekday, A is for full weekday name, here's C, date and time. So I went through and this is ones we use quite a bit, but so here's lowercase year without century, here's year with century, so this is what we're using for year. And so these are all organized in here alphabetically, but this is what we're going to want. And when we run this, we are going to get, again, arc time, but it's going to be changed into a POSIX time, so it's an actual date. So R knows it's a date. So you see we just have a GMT on this. So that's good. All right. And then finally what we're going to do is just designate the fourth column as the CIS index or CIS extent. And that's easy enough. We're going to make an object called arc.sie for CIS extent. And we're going to use the assignment operator, and this is going to be arc4. Okay, so the head of arc CIS extent. So those are the first few numbers of the CIS extent. So that's good. Okay, and we can always go back and check our original data set. Here's arc. We can click on this. Here's 1978-10-26. Okay, that's our time. And here's our CIS extent, 10.231, 10.420. That's what we're seeing here. Okay, all is good. All right, so let's go ahead and close this. And now we're going to do the same thing for the Antarctic data set. So let's go ahead and do that. So let's just copy this. And we're just going to call this Ant for Antarctic. And we know that we have to get our FTP site from here. Right? This is our Antarctic data. Right? And let's make sure that reads in. Let's go ahead and read it in. Let's put a tag here. Right? Still reading in? Okay, there we go. There's our Antarctic data. And we're going to use some of the exact same functions here. So I'm going to copy this. And we're just going to be the Antarctic. And this is now, we're just using the first few rows. Should be able to run that. Okay, looks so far so good. And we are now going to deal with the Antarctic time. Copy that. All right. Should be in the exact same format. We can run that. Good. Okay, we have our Antarctic time there. Let's just take a look at it. Good. Okay, so there's our dates. And then finally, we'll designate the fourth column as our Antarctic sea ice index. Good. All right, so now we're ready to plot these guys. So let's go ahead and make a note here to ourselves. Plotting the record of Arctic and Antarctic sea ice extent from 1979 to present. So we're going to use our plot function again, plot. And what are we going to do? We're going to plot, we're going to go ahead and start with the Antarctic time. That's going to be our x. And where we say x equals our Antarctic time. Y equals our Antarctic SIE. Let's make it a line. Type L. Let's go ahead and look at that. What do we got? All right. There it is so far. lots of oscillations, right? These are daily values, and we see all the seasons in there. Lots of lots of annual variability, so big seasonal changes. And let's go ahead and increase the line weight. Line equals 2. And the color, let's make it gray. I think we used gray last time for Antarctica. Okay, all right. Okay, and we're going to have to add a X label. In this case, our X label is just going to be date. And our Y label is going to be sea ice extent. And let's do a main. Daily sea ice extent. Remember, this was in millions of square kilometers. All right, is there anything else we want to put in here? Let's go ahead and run with this. Okay, good. Oh, looks like I'm missing the last parentheses here. Try that one more time. Good. All right, so now what we're going to do is go ahead and add, using similar to the points function, we're going to use the lines function, where x is now going to equal our Arctic time. We're going to add the Arctic data to this. Y is going to equal our arc SIE. Type is going to be a line. Line weight is going to be 2. Our color is going to be black. Let's go ahead and add the Arctic to this. All right, okay, so much less annual variability, and looks like there might be a decreasing trend there, but we can check that in other ways. And let's go ahead and add a legend here. I don't have a whole lot of room for a legend like I did before, so one way to do that is to adjust your y-axis. So let's come back up here to our line 34 here. Let's do a y limit. Let's go from 0 to 20. And if we replot all of this again, see that we got a little space down here now. Okay, so our legend in this case is going to be x. That's going to be in the bottom right. X equals bottom right. Arctic and the quotes. Antarctic. Our line weight is going to be 2, and our color is going to be, let's see, Arctic was black. Use the concatenate function. Gray. All right, how's that looking? Okay, yeah, we still got that box in there. So we ran into that problem last time, so let's do the box type equals n, and the horiz equals true. That makes it a horizontal legend, and we'll just copy this whole thing again. All right, that looks much nicer. All right, you'll notice that most of the variability is seasonal, but it looks like there might be some interannual changes. In other words, it looks like these successive peaks might be getting lower here in the Arctic, or maybe that's not the case, or is the case here in the Antarctic. And the folks over at the National Snow and Ice Data Center make it easy for us to look at that question to say, well, is it really going down? And one way to think about this is it the same level every March, or is it the same level every January? Is it the same level every September? And what we can do is actually look back here. We go back to our initial place here where we got it. We can go to North, and we can click on Monthly and get the data. And here we have one file for each month. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 months. These are CSV files, and we can go ahead and read these data in for every month. So we can go ahead and click on one, see if we're looking at March. Here's every year for month 3, which is March, and it gives you the extent. All the way down, here's the near real-time stuff, so it hasn't been completely checked, but probably pretty reliable. Maybe change a little bit in 2016. And here's the extent and the area. Well, we can write code to read this in. So let's read in the Arctic sea ice extent for March and September. Alright, so let's call this arc_March. Read.csv. Alright, what's our file here? This is for March. Okay, can we look back at this and see if there's anything interesting? Looks like we got a header, just one, so that's nice. So let's just write header equals true. Right, so we should be able to get that. There it is. Okay, so far so good. Right. And let's do the same thing for arc September. September. Read.csv. March is typically one of the highest in the Arctic, and September is one of the lowest. Remember we saw that in our seasonal graphs last time. So let's just go ahead and go back and take a look at September. There we go. There's the September data. Put this in here. Header equals true. And we can read that in. Okay, all right. 3 observations of 6 variables. Okay, so, and now let's just do the same thing for reading in the Antarctic. All right, I'm just going to copy this, and we can modify it. Antmarch, and let's go get the right FTP. Let's go back, go into the south directory, daily, data, whoops, not daily, monthly, data. There we go, let's go ahead and get March. Take this out, copy and paste our new one in. All right, so there's south, yep, 3rd month, so that's good. And also for September, let's edit this a little bit. Let's go back to our site. And here is September. Copy that. All right, good. We should be able to run this. Good. All right, now all we need to be able to do now is to plot these things. So let's write a little bit of code here where we're going to plot the Arctic March, column 1, right? Because if we look at Arctic March, here it is, on the table, column 1 is year, right? And then we're going to plot extent. So that's column 1, 2, 3, 4, 5 is extent. Okay, that works out. So column 1, so this is going to be x equals a year, and our y equals arc mar column 5. Let's do type is O for overplotting. So lines and circles. Let's see what that looks like. Oh yeah, okay, so alright, so you can clearly see that looks like there's a decrease in March over time, quite a bit. And we'll look at that a little more closely. So that's going to be the highest amount of sea ice in the Arctic. Line weight equals 2. Let's add an X label. In this case, it's going to be year. Our Y label is going to be sea ice extent. Okay, and our main is going to be monthly sea ice extent. And this is in millions of square kilometer. There's the end of the quote. And close the parentheses. All right, let's see if that works. Yeah, okay. All right, let's see if we can add now. Add points for x equals Arctic September. Y equals Arctic 5 O 2. All right, let's see what we got here. All right, we added points, but they didn't show up over here. And that's probably because if we look at the values of Arctic September, in fact, we can just look over here. There it is. You notice that they're much lower. 7, they should be, because that's when we have very low sea ice. So they're not on our scale. We only go down to 14.5. So what we're going to do is come back to our code here and put a y limit from 0 to 20. So this is going to set our y limit. Yep. And now we're going to add our September. Okay. But it looks like here that, so here's our September and our March. We're going to have to label these differently. So maybe what we'll do in this case is give this one a PCH equals 20. So if we plot these two together, the second one now is solid lines, this is open circles, and so now we can write a legend. X equals bottom left. Concatenate mar. In September. ch 1 and 20. So the point character for the first one is 1. In fact, we can just make that explicit up here. There you go. Line weight equals 2. And let's just do horiz equals true and bt box type n. All right, we're looking good. All right, so there's March and there's September. So clearly downward trends in both cases, year over year. So we've taken the seasonality out of it. Now we can do the same thing for the Antarctic, and we can just copy this whole piece of code and just edit. So here now is Antarctic March, Antarctic March, Antarctic March, Antarctic March. All right. We should be able to do that. Okay. Now, doesn't look so clear that there's a downward trend in either one of these two. But I just noticed something that we didn't do, is which we didn't label this very well because it's hard to tell which is Arctic and which is Antarctic. So I'm going to come back up here to line 49 and I'm going to put Arctic monthly sea ice extent. Let's make this plot again. Okay, Arctic monthly sea ice extent, millions square kilometers. That's a little nicer. This is a little bit long up here, so what we're going to do is in this main function right here, we're going to type a /n, and what that does is that's going to break the line. That's R is going to interpret that as a line return, and you'll see what happens. There we go. Arctic monthly sea ice extent, millions of square kilometers. Okay, and we can do the same thing down here. Sea ice extent, put R/n, millions of square kilometers. Let's plot this. Ah, yes, okay, so two very nice plots. And you've done it there. We can look at year-over-year changes, we can look at different months, you can see how this progresses through the class, and see what happens to sea ice extent.